Okay, so this is the enclosed area, which is the same as some of the others. We have y equals x squared plus 1. That's the parabola. We have y equals 2. That's the horizontal line. And then the new one, which we haven't had yet, which is x equals positive 8, which is the vertical line. Okay?
7? X equals 7, right?
Oh, 7. Yeah, you're right. Yes, I did it right. I just put it wrong. Thank you. Yeah, x equals 7. Good. Okay. Okay, so the difference between this one and the ones we were doing yesterday is we are revolving around a vertical line now. So we're revolving, so that pink shaded area is going to revolve around the green. Okay, so it's going to create a three-dimensional around the green x equals 7. So that's going to be dy. Okay, we've done dy in the past. We did it last week with, or earlier this week with disk method. Similar. Okay, so remember, when we're big R and little r aren't going to be top dot to bottom dot. It's going to be right dot to left dot. Okay, so when we're trying to decide where the right dot is and where the left, where big R and little r are, always start. So what I do is I look to see where the shaded area is. The shaded area is over here. Where is the axis of revolution? Right here. So I'm going to pick somewhere in there. Okay. Big R goes from the axis of revolution towards the shaded area. And you're going to go through the shaded area until you get to the outer bound. So I'm going to go right to left, and that's where my next dot is going to be here. That is big R. So the right function is x equals 7. The left function, or the outer, is going to be the parabola. Okay? I'm going to do the same thing. Now I'm going to extend only to the inner. So I'm not going to go through the shaded area. So I'm going to stop there. That's little r. Okay? All right. Okay. So we know where r and we know where little r. So let's write our equation. Write r. It's the same formula. Pi's in the front. Not worried about the bounds yet. We'll worry about the bounds later. Big R minus little r, squared minus little r dy. Okay, so let's start with big R. Big R is 7 minus x squared plus 1. What's wrong with that? Why can't I put, yeah, x squared plus 1, right? This is dy, so they only want y's in here. So I have to solve for y. Okay? So it's y, let me erase this first. It's y equals x squared plus 1, right? So I have to solve for y. Let me get out of the way here. So that means I'm going to subtract 1 from both sides. Square root. And when we're solving and we have a square root, remember, it's always a plus and a minus. It's always a plus and a minus. Okay? Sometimes x will be positive, sometimes x will be negative. Okay? So let me change this guy now so that it's more in line with what I'm trying to do here. So x equals plus or minus square root y minus 1. That's the one I have to use. So it's going to be 7, right? Minus, which one is it going to be? Positive or negative square root? It's not going to be both. It's going to be negative. Yeah, why negative, Damien? Because it's on the other side, right? On this side is where the x's are negative, right? So it's always going to be a negative value for x. So this one, it hits this side of the parabola. This side of the parabola are only x values that are negative. It's in these quadrants where x are negative. So we're going to subtract negative square root y minus 1. So in other words, it'll be plus. Little r starts with 7. And then it also hits the parabola, but it hits the positive side of the parabola. It hits it hits this side where x's are all positive. So that's where it's going to be positive. So it's going to be 7 minus y minus 1. So one of them has, so they look the same, but they're not. I've had some students say, well, don't they cancel each other out? No, because they don't say the same thing. One says 7 minus a negative, which is really positive. And the other one says 7 minus. Okay, so be careful there. Last thing, bounds, the bounds. So again, it's with respect to y, dy. So now we're looking for the y values. The y values of, well, one of the y values is 2, right? The y is 2, so that's going to be the top bound for the integral. The bottom, where is that dot at? 1 or negative 1, right? Is that negative 1? No, positive 1. It's positive 1. Yeah. That's the y value there. Calculator. So verify you got this, or if you didn't get it, let me know. Okay, 58.643. All right. So there's one more that's dy, which is 6b. So take a look at 6b after you verify this. Take a look at 6b, and then I'm going to have you do 6c on your own using whatever methods you need to. And then I'll let you start on the practice after that. The practice is both washer and disc, but like I said, if you don't know, use washer. Washer always works, just there'll be no little r. Okay, so next thing we're gonna do is 6b. It's the graph we were working with yesterday, just different question. So the parabola part is y equals 2x cubed. Then we have a vertical line, not squared, cubed, squared, right? Let's see. Squared. And then we have a vertical line, x equals 2. And we also have a vertical line, x equals 0. And then we have y equals 0. Okay. So this one, we're also revolving around a vertical line. We're revolving around y-axis. The y-axis is a vertical line, x equals 0. Okay, so I'm going to highlight that. I'm going to highlight the revolving line so it kind of sticks out in blue. Okay. All right, so let's set up our big R squared minus little r squared dy. Okay, so first big R. Now we're going to move either right or left. We're not going to move up and down because this one's not dx. Okay, so I'm going to make a dot somewhere along that blue line. Anywhere along the blue line. You can move that dot higher, you can move that dot lower, somewhere where the shaded part is to the right. So I can move it all the way up here, I can move it down here. I don't want to go below the x-axis because then there's no more shaded part. Okay? Now I'm going to go into the shaded part. I'm going to go through the shaded part and stop when I get out of the shaded part. That's right here. That's big R. Big R always goes from the axis of symmetry through the shaded part to the outer bound. Little r starts same spot, but it doesn't go through the shaded part. It stops at the shaded. Okay. So this is dy, right? Remember, this is dy. X equals 0, okay, because it says x equals. X equals 2, okay, because it says x equals. Y equals 2x squared, not good, right? We got to change that one. So y equals 2x squared, we got to solve for y. Or sorry, x. So divide both sides by 2, so you get 1/2. Square root both sides, you're going to get a plus and a minus again. So we get x equals positive and negative square root 1/2 y. Okay. Yep.
Where should you get x equals 0?
X equals 0. Right here. The blue line is x equals 0. The y-axis, another name for the y-axis is x equals 0. Another name for the x-axis is y equals 0. Okay. All right. Okay, so now let's go big R. Big R, we go right minus left. So even though we started left and went right, it doesn't matter. We always go right minus left when you're doing R and big R and little r. So the right is x equals 2. So 2 minus. And then we extend to x equals 0, right? Mm-hmm. So it's just 0. That's big R. Little r ends in the same spot, 0, but it starts on the parabola. Which one, the positive version or the negative version? Positive version because we're positive x's. So it's going to be positive square root 1/2 y minus 0. Because that's where I ended. Last thing is the bounds. Y value bounds. So here's 1 up here, and then down there will be this. So 0 I know is the bottom because that's the x-axis, y equals 0. So this top guy up here, looks like that is 8. You can verify on a calculator, but it's y equals 8. because we're dy, we're not dx. If this was dx, that would be 2. The bounds would be 0 to 2. But because this is dy, it's 0 to 8. Calculator. And hopefully you get 50.265. That's the volume if the shaded part revolved around that blue line. It kind of create a big bowl. Or like like a vase, like vase, however you say it. Yeah. Okay. Okay. Do the last one. Do C.
Boom.
Okay, so we have the same function, the same shaded area, but now we have a different line of revolution. It's a horizontal line. Going back to horizontal. So it's a dx. Okay. So we got volume equals pi r, capital R minus little r dx. Okay, so we start at the axis of revolution. Always start at the axis of revolution. There's only one way for me to go to get to the shaded part. It's down. So that's how you know which way to go. I got to go down, and I'm going to extend until I go through the shaded part to the other side. That's big R. Little r, you're going to start on the same blue line, except you're going to go down until I hit the shaded part, and then you're going to stop. Little r. Okay. Top to bottom, top dot to bottom dot. So big R is 8 to 0, 8 minus 0, which is 8 squared, which is 64. 8, little r is still 8, but it's minus the function, right? And I don't have to use, I can use the y equals version because it's with respect to x. So it's going to be 8 minus 2x squared. Bounds, x bounds, 0. The shaded area is from 0 to 2 for x. So like you did on number 2. The same bounds you use for for 6a. Because that was also dx. And when you do that, you should get 87.6 or something very, very, very close to that guy right there. Okay. What was I going to say? So the rest of the time I'm going to give you to work on your practice. It's not due till Monday. Because I wasn't going to assign it till tomorrow, but I finished. You can get it started early. So you have the weekend to finish. Tomorrow, though, I was going to give you a day to do the practice, but I want to get done with a chapter. Because we have one more lesson left for this entire course, and we're done. So I want to possibly finish it by Friday. So we're probably going to do that. So I'm going to give you the last set of notes tomorrow. Okay, we'll do that. All right. Okay.